Hello, Mr. Westwater here, and I'm about to take you through the AC method for factorising quadratics, but I'm going to do it a little bit earlier than you may normally see it. This is normally a method used when there is a number in front of x. Now here, the number is just 1, so we don't write it down. It's a, we would say, is 1. The AC method refers to the fact that the value in front of x squared is often called a, and the final term is often referred to as c, and you'll see this a little bit more when we come to the quadratic formula. But for now, we're just going to have a look at factorising this. Now, different to the factorisation you might have seen so far, quadratic factorising leads us to two brackets. Okay, now you might remember this from when we've expanded two brackets, we end up with three terms, where one is squared, one's a single term, and the other is just a number on its own. Now, there are various ways of approaching this, but as we build up in complexity, there's a general method most people use, but it can actually be used a little earlier. So I'm going to go through it now so that we're familiar with it, so it's not this big thing when we come to it. Okay? But know that we're going to end up as two brackets. But the only skill you need for this is to remember that if you had something like x squared plus 3x, this would go to x plus 3. Yeah, you're just taking out a common factor from each thing. Okay, let's get rid of that. And our first step with this method is to say, well, can I rewrite the x term, so this plus 3, with two factors of the constant at the end? Okay, can I rewrite this as two factors of this? Now, I've chosen this as an example for the first one because it's fairly straightforward. Our factors of 2 are either 1 and 2, or they could be minus 1 and minus 2. Remember, two negatives could make a positive as well. However, the only two which will sum to the middle term are going to be plus 1 and plus 2. So what I'm going to do is I'm going to rewrite this x squared, but instead of 3x, I'm going to write it as 1x plus 2x plus 2. And actually, it doesn't matter which way round you write this, because actually you could have written this as x squared plus 2x plus 1x plus 2. And that would also work. Okay? So we'll come to both approaches later on, but let's just focus on this one on the left. Now, I'm going to split this in half, okay? I'm going to draw an imaginary line down the middle, okay? And I'm just going to factorise each bit separately. So x squared plus 1x, x is our common factor here, and if I just factorise this linearly, this would go into x plus 1, okay? And on the right-hand side, I've got a common factor of 2, and this again will actually go to x plus 1. Now this is important, okay, because my bracket on each side needs to be the same. And it should always be, okay? It would also be going down this route, okay? We'd actually have a slightly different bracket, but we'll see that shortly, okay? And now, the way I'm going to sort of explain this is if we had x times a plus 2 times a. Do we see that a is a common factor here? So if I wanted to, I could factorise this expression as a into x plus 2. Yeah? Now, in this particular case, our a is actually our bracket. X isn't multiplying a, it's multiplying x plus 1. And 2 is multiplying x plus 1. So instead of thinking about this as xa, and what I'll actually do is I'll just shift this down a little bit, xa plus 2a, I can think about this as, and actually let's get rid of this line down the middle, our common factor instead of a is x plus 1. Okay. Now what is x plus 1 multiplying? It's multiplying x, and it's multiplying plus 2. So this is our second bracket. Okay. So the fully factorised version of x squared plus 3x plus 2 is x plus 1 times x plus 2, and you can multiply this out, you can expand it. That's also a good way of checking. X squared plus 2x plus x plus 2 gives you x squared plus 3x plus 2. Okay, so this does fully expand properly. Okay, so our fully factorised equivalent is this. Okay. Now I said earlier that we did make a choice earlier. We wrote plus 1 and then plus 2, but if I'd have written it the other way around, I'm just going to show you that this will also work. So again, let's imagine that we've got a line going down the middle. Ooh, it's not the best of lines, let's try that again. Okay. And I'm going to factorise each individually. And remember, we want a consistent bracket on each side of that line. Okay, so on the left-hand side, x is our common factor, but this time we'd get x plus 2. And on the right-hand side, it doesn't look like there are any common factors here. So what I'm going to do is I'm going to say plus 1 times x plus 2. Okay, and again, notice how we've got the same bracket. Sometimes you might even skip ahead and know that you've got a common bracket there, and after you've found your first one, you can just insert it and then work backwards to find the number that's going in front of it from above. Okay, so again, we've got x plus 2 now is our common factor, so this is the thing I'm taking out. And what do I need to multiply this by? Well, on the left-hand side, I'm multiplying it by x, and on the right-hand side, I'm multiplying it by plus 1. Okay, so we do actually have the same answer here. Instead of x plus 1 times x plus 2, we've got x plus 2 times x plus 1. These are the same because multiplication, doesn't matter which way you write it down, 3 times 4 is the same as 4 times 3. So we can say x squared plus 3x plus 2 is x plus 1 times x plus 2, or x plus 2 times x plus 1. So there are 3 main steps here. First, we need to rewrite the coefficient of x, so that's our middle term here, as the sum of the 2 factors of the constant. Okay, so we rewrite this with 2 factors of our final value. Now this is going to change if these are not both positive, and we'll see that coming up. Then we factorise the first 2 and the last 2 terms separately. So I factorise these 2 together, and I factorise these 2 together. And then my final step is to factorise the final expression, taking out the common bracket. So here our common bracket was x plus 1, so I took that out, and then I said, what am I multiplying this by? X and plus 2, and that built my second bracket. Okay, so let's have a look at another example. X squared minus 5x plus 4. So again, my first step, so I'm going to have a look at the constant on its own, plus 4. So this can be written in a number of ways. It could be 1 and 4, if I'm thinking about factors. It could be 2 and 2. But neither of these will sum to minus 5. Now this isn't just 5, it's minus 5. So what I've forgotten is that this could be the product of 2 negative numbers. It could be minus 1 times minus 4, or it could be minus 2 times minus 2. And in this particular case, this minus 1 and minus 4 will sum to this middle term. So let's rewrite this, and I'm going to put minus 1x first, and then minus 4x plus 4. Okay, again, you could write it the other way around, and if you want to, as an exercise, you can have a go at this written the other way around. You should end up with the same answer that we'd get. Okay, so let's factorise each of these separately. So let's focus on the ones on the left-hand side first. Okay, so x is our common factor, and this is quite easy. This would just be x minus 1. Okay, now this is a little bit trickier because I know 4 is a common factor, but if I put plus 4 here, yes, then when I factorise it out, I'd get minus 1, and then, minus 1x plus 1, which is close to, these brackets are close to each other, but they're not quite the same. So what I'm going to do is actually, as I mentioned earlier, I'm going to write this, but the other way round. I'm going to start with the bracket I know I'm ending up with. So I'm going to say x minus 1. Now, what number needs to go in front of this? Well, it's not going to be plus 4, it's going to be minus 4. Okay, and this is where these do get a little bit tricky. Okay, if we had minus 4, wrote minus 4 down first, hopefully you can see that this would have to be negative to get a plus 4 when you expand it out. Okay, anyway, now we have a consistent bracket, so we can take that out as a common factor. And what are we multiplying this bracket by? Well, over here we're multiplying it by x, and over here we're multiplying it by minus 4. And that's your answer. Okay, next question. We have minus 15, so again I'm thinking of all the different ways I can make minus 15, so we could have 3 and minus 5, we could have minus 5, we could have minus 3 and 5, we could have 1 and minus 15, or we could have minus 1 and 15, and I don't think there are any other ways of going there. If we have a negative here, then it has to come from a positive times a negative. So now I'm looking at this plus 2x, and I'm thinking, well, if it's plus 2x, then it's got to have a larger positive number. So it's going to be this minus 3 and plus 5. That will get me my minus 2. Okay. So let's rewrite this, and let's write it as plus 5, just to make it a bit trickier for myself, I think. Okay. So x squared plus 5x minus 3x. It's always a little bit harder if you have the second term negative for the reason that's above. I'll actually do this one 2 ways, and then you'll see what I mean. So x squared minus 3x plus 5x minus 15. Okay, so we'll factorise both halves, take a factor of x out, x plus 5, and again remember we want both brackets to be the same, and I've got a negative here which could cause some concerns. So what I'm going to do is I'm going to make sure that the brackets are the same first, and what number has to go in front of this? Well, it has to be a minus 3, and that will get me my minus 15 at the end as well. Okay, so now I take out a common factor of x plus 5, and what am I multiplying x plus 5 by? X over here, and minus 3 over here. So this fully factorised is x plus 5, x minus 3. I'm just going to show you it over this way, and why this is probably a little bit easier if you have a positive term over here. You can just jump straight in a little bit more. We'd have x brackets x minus 3, and then you can just write straight away plus 5 brackets x minus 3. 5 is a common factor of 5 and minus 15, so you can sort of just jump in straight away a little bit more there, although you should be careful. The key thing is that the brackets will have to be the same, because in your final step, x minus 3, you need to be able to take it out as a common factor. And again, we've got x minus 3 times x, and we've got x minus 3 times plus 5. Okay, final example. X squared minus 6x minus 16. Okay, so again, I'm going to think about minus 16. It has to come from a positive times a negative. So let's think about this as, this could be 1 times minus 16, or minus 1 times 16. It could be 2 times 8, or minus 8, or it could be minus 2 times 8, or it could be 4 times minus 4, and actually that's our last combination, isn't it? Okay, and again, we're looking for a combination of these which will sum to minus 6, so I can rewrite this as a combination of two of these. Can you see it? Yeah, it's this one here, 2 and minus 8. Okay, so I'm going to rewrite this as x squared plus 2x minus 8x minus 16. And again, take a common factor out of each side. So this is x plus 2. So I know my bracket over here is also going to be x plus 2. And what number now needs to go in front of this? Minus 4. Oh, that doesn't work, sorry. No, minus 8. Okay, and that will definitely get me my minus 8x and also my minus 16. So my final step, x plus 2 is the common factor. So x plus 2 times x minus 8. As I said, there are quicker ways of going about it. And in fact, one of the things you may have noticed is that these two numbers, which we originally broke it down into, are always the final two numbers in your brackets. But that's only going to be the case when there's just a 1 in front of this. Okay, but we'll come on to how this method is more helpful with other examples a little later on. But I'll just sort of show that. If you didn't notice this already, I'll go through the examples and you'll be able to see. So remember, we split this into plus 5 and minus 3, and we ended up with plus 5 and minus 3. We started off with minus 1 and minus 4, and we ended up with minus 1 and minus 4. And we split this one up into plus 1 and plus 2, and we ended up with plus 1 and plus 2. Okay, and plus 2, plus 1, plus 2, plus 1. So it's no coincidence that this happens, but this will not necessarily be the case with harder examples. So it's dangerous to think that this is a common pattern. But if you wanted to jump straight in and you notice two numbers which multiply to this number and sum to this middle one, you can just put it straight into brackets if the value in front of x squared is 1.